Thanks very much. I think I'll just stand here if that's okay, because I want to point at the board. So thanks very much for the invitation to CAPI. Particularly thanks to Professor Wu for picking such a great topic, very important topic, and a very timely topic. It's my first attempt to deal with climate change issues and to try and put together what I call sovereign security with sociological or societal security and see how they work inside Asia. I think I really had two assumptions before I started the paper. One assumption about the scientific part of the paper, which comes first, and the other one about the human security part, which comes second. I had kind of separate assumptions about each of them, and both of them proved to be wrong. The assumption I had about the scientific part was that the scientists, the climate scientists, would be quite cautious and quite conservative about their thinking about climate change in the Himalayan region. You might remember in the IPCC 07 report, there was a very strong claim that all glaciers would go by 2035, and the climate change skeptics jumped on that, saying there wasn't science to back it up, and it turned out to be right. So I kind of presumed from that they would have all kind of drawn back and come up with much more conservative assumptions. And actually, in fact, the reverse is true. What I'm going to talk about is the degradation of the Himalayan water tower as a committed event. The scientists are not talking about this in terms of mitigation, which is their way of saying we can adopt policies that will slow it down. They're actually accepting it as a committed event. And it's really only open to adaptation, that is policy adaptation, social economic adaptation. So that was the first surprise. Second one was about the security part. I rather assumed that when I got to looking at the security analysis, either in China or in South Asia, particularly in India, that there would be a lot of stuff on this, that lots of people would be discussing the relationship between water security or transboundary issues and sovereign issues. But that is not the case. In China, there's pretty much a kind of a complete bifurcation between the science world and the security world. The scientists have more or less been delegated control over this issue, saying that's your issue, it's a science issue. And the political scientists or the security and the analysts are mainly sticking to the traditional remit of discussing sovereign security issues between China and South Asia, particularly between China and India. In the Indian case, there's a little bit of movement. I'll come on to one source in particular, which comes from the main Indian security think tank. But even though they're discussing the impact of change to the water security position on the Himalayan region as having implications for China-South Asia relation, they still see it very strongly through a sovereigntist lens. In other words, they're not approaching it from what we're discussing as human security issue. They basically use sovereigntist assumptions about security, sovereigntist categories, sovereigntist interests to define this whole question, and I'll come on to that later on. So from that, the next starting point for my assumption is, this is a statement which appears in a lot of not so much the communiques coming out of the Sino-Indian summits, but tend to be the press conferences and statements that go on the fringes of the recent Sino-Indian summit. They've taken to saying that Asia will be big enough for both China and India in the 21st century. Now, my response to that, as a European, of course, somebody coming from a continent in which had several rising powers at one time and proved not to be big enough for all of them, my response to that is, if it's true, then that's great. We won't worry about something else. We won't have to worry about this. But certainly when you look at the data, it's pretty daunting in terms of what it suggests. By 2020, China-India population will be 60% of Asia, or 36% of the world population. The drive towards urban population will continue. This is 2010 estimates of 45% and 30%. GDP now combined is about 44% of Asia and about 16% of the world GDP. But projections moving forward to 2030 suggest a combined GDP of about 28%. So So the difference between that figure and that figure suggests that China and India are actually only halfway towards industrialization, or only halfway towards urbanization. There's still a long way to go over the next 20 years. In terms of carbon emissions, they're at 22%, which clearly is less than half of highly developed carbon emissions. Differences also, as we keep pointing out, in terms of per capita footprint, combined at 4.5 kilotons CO2 compared to 10. It's also the case that they are making significant improvements in carbon intensity of growth, but China in particular coming down from the 1.3 to 0.7 kilotons CO2 per billion US dollars. But as Joanne's paper pointed out this morning, that's a great once and for all change. It will be incremental changes going on. So there's a kind of an issue to do with continued industrialization, urbanization, and the impacts on climate change drivers in terms of emissions and in terms of carbon intensity. Clearly that tends to focus our attention on this region, which is the high region between China and India, which has a very kind of unique and separate ecological system. This has often been called the third pole because it's the third largest source of water on the planet after the two poles. About 8,000 cubic kilometers of fresh water which is frozen above 4,000 meters. And that's about 6% of the world's surface water. I mean, I tend to think of this and how much of Lake Baikal is that. Lake Baikal is the biggest source of fresh water on the planet. It's about 20% of all surface water. So it's about a third of that. But nevertheless, this is a more important system than Baikal because all the Siberian rivers, of course, flow away from population and these systems move towards population. And they are self-replenishing systems. This is actually a very old ecological system. The ice up at high levels has been dated back 700,000 years. So it's essentially a self-replenishing system that's very old, before the creation of all the modern, all the classical Asian societies. It feeds more than 10 major river systems with population of nearly 1.4 billion, 1.34 billion. And we're dealing, even though I'm calling it Trans-Himalayan region, the Himalayas are only one of the ranges involved. There's actually 6 main ones: the Himalayas, the Karakoram, the Hindu Kush, Pamirs, the Kunlun, and the Tian Shan. All of these have significant glacier systems or ice pack and snow systems, which then feed into the major river systems round about. However, climate scientists are pointing out that temperatures above 4,000 meters are actually rising faster than global warming, twice the rate of global warming, about 0.3 degrees centigrade per decade. And then the research by Menon et al., they're plotting the decline in snow cover, which you can see here, and it maps out the 6 ranges quite clearly: Himalayas, Karakoram, Pamirs, Hindu Kush, Kunlun, Pamirs here, and Tian Shan. So this decline in snow cover, it will translate over time into declining runoff and feed into the river system. But radiative forcing from greenhouse gases is not enough by itself to explain these changes. So the scientists have been looking at explanations of why it's getting hotter above 4,000 meters than it is at sea level. And the explanation there is that we're dealing with dual systems of anthropogenic climate change. That's radiative forcing from greenhouse gases at what's called top of atmosphere, but also the impact of black carbon aerosols. These are different from the just carbon discharge in coal and transport systems because they mix in biomass as well to create these what are called atmospheric brown clouds that we associate with Asian industrial areas, as clearly East China with the Korean Peninsula and the clouds hanging over it. And this is the Bay of Bengal, the Ganges, Brahmaputra Delta, and the Himalayas in the back. Now, the man who knows all about this is the gentleman at the top left. His name is Professor V. Ramanathan. He's from University of California, Southern California, San Diego, and he's studied the impact, the interaction between the greenhouse gas discharges and the black carbon situation. And so the conclusion here is global climate model simulations suggest that advection of warmer air heated by black carbon from South and East Asia over the Himalayas contributes to a warming of about 0.6%, 0.6 degrees centigrade an annual mean. This is as large as the warming trend due to greenhouse gases, leading to the inference that BC forcing is as important in greenhouse gases in the observed retreat of over 2/3 of the Himalayan glaciers. So it's a combined effect of both the low-level brown atmospheric brown clouds and the higher level greenhouse gas effect, which is eroding the glaciers and the snow. This is a climate model simulation which does not take into account the second effect, black carbon effect. It's only based upon committed greenhouse gas warming. As we know, the IPCC element was a committed equilibrium warming of 2.4 degrees. That's what Copenhagen was trying to aim at, holding the industrialized nations to that and hoping to persuade developing countries to commit to it later. That means that that peak there is represented by 2.4 degrees. Everything to the right of that peak is open to mitigation. In other words, it can still be adjusted due to policy interventions at national, regional, or probably global level. But everything to the left of it is assumed not to be open to mitigation. We're only talking about adaptation. So, and you can see that Himalayan Tibetan glaciers are to the left of the peak. Therefore, even without black carbon forcing, the Trans-Himalayan Glacier Retreat is a committed event. It's open to adaptation, social, economic, and so on, but it's not open to mitigation. So the next estimate is what rivers will be affected and what populations, and this is an estimate from Su 09. The two main variables, of course, are the share of melt and flow, because we're not suggesting that all the rivers are equally or predominantly dependent upon glacial melt, and also the important question of population density in river basins. This suggests kind of like four categories to me. At the very top, we have the Ganges and the Yangtze, and these have very high population densities, and the Yangtze seems vulnerable at 18% of melt and flow. We then have the second category of Brahmaputra, Indus, and the Yellow River, and the Indus clearly stands out there with nearly 45% melt in flow, suggesting that this population here, effectively, most of the entire population of Pakistan will be affected by the decline in melt. Further down, we have Irrawaddy, Mekong, and Amu Darya. Amu Darya particularly seems to be vulnerable. And then at the bottom, the Salween, and probably turn out to be the most significant case in China, and that's the impact on the Tarim and South Xinjiang. So you have the highest population effect on the Yangtze, but the biggest overall effect will be on the Tarim, which depends upon the melt from the Tianshan, and with it, a particular type of very old agrarian community which depends upon glacial melt and the Karet system to run oasis agriculture. So you have a diverse picture there, but particular points of vulnerability either due to the share of melt and flow or in terms of population density. If we take a quick look at the World Water Development Report's projections on water scarcity in terms of Asian subregions, you see how there's a really quite strong correlation between changes to the water tower on the Trans-Himalayan region and what's happening round about it. So northwards you see this band of water scarcity across all of North China, Xinjiang, and leading into Central Asia, with Uzbekistan, Kyrgyzstan, Tajikistan, and parts of Afghanistan clearly affected. To the southwest, most of Pakistan and also Indian states, Punjab and Rajasthan, will face water scarcity. For India as a whole, the main issue may actually be developmental scarcity, that is, economic water scarcity here. And then you have the rather strange position, almost a unique position, I think, where you have different projections for water scarcity or water security in North and South China. That's actually quite rare to have that kind of separation inside a single country, where half of the country effectively will be water scarce, and the other half of the country will not face water scarcity. And it's from that possibility that you get the suggestions that China will attempt to divert water, involving really quite complex engineering schemes from South China, including the Tibetan region, to try and stem off the scarcity problem in North China. So that's the end of the science part. Let's go on to the human security part. Helen, how much time do I have left?
You've got about 7 minutes.
7 minutes, okay. So what I think we're going to see, if these projections are correct, is I think we're going to see political mobilization around ecological claims. In other words, in the paper I cite, the old statement from E.H. Kerr that international politics has always been driven by the struggle between haves and have-nots. And we're going to see an equivalent struggle between ecological haves and have-nots that will be played out within Asian societies, but also potentially between Asian societies. So perhaps ecological colour revolutions, perhaps ecological security dilemmas. And at the core of that will be the question of water security. So as the World Water Development Report says, carbon is a measure of the anthropogenic causes of climate change, but water is a measure of its impacts. So water is actually central to most of the other human security issues like food and energy and climate change. So why is water so important? So first of all, it's part of a cycle that is between rainfall or snowfall to runoff to consumption in either farming communities or industrial or in urban communities. And anthropogenic climate change will actually impact each part of the cycle. It will drive excesses and shortages, though in our regions the general trend will be towards shortage, including a secular decline in the strength of the monsoon season. It's also the case that unlike food and energy, water is self-transporting. It doesn't require people to go and get it before it becomes part of the security chain. The way that water moves, either in excess or by shortage, will therefore drive population movements, and it will ultimately drive migration, including migration across boundaries. The final thing is to do with the role of water in Asian hydrocultures. Every primer on Chinese history begins by telling you that China was built around a particular kind of hydroculture in North China, which was then extended with rice culture to the south of China. So the impact on water supply will actually form a transmission belt for transboundary human security between these different hydrocultures. It will actually impact people's assumptions about, not just the economy of the society, but sustainability of different communities. So water is going to be at the center of those human security issues. Of course, there has been some attempts to get transboundary water agreements in this region, but none of them to date have involved China's direct involvement. I mean, there's been a lot of discussion in recent years, including in this conference series, I think, about China's multilateralism. But there's no evidence as yet that China's prepared to make any kinds of formal or direct commitment to multilateralism on managing water issues. There are agreements between India, Bangladesh, and India, Pakistan. The controversies there tend to be about implementation, and particularly about whether India is telling the truth about water sharing arrangements. But China and its southern neighbours, there has been no movement in this area. There's very limited transparency. Neither India nor China publish proper hydrological data saying, what flows are, what consumption is. And there's been no consultation on infrastructure plans. All infrastructure plans are treated as being part of domestic national planning, and there's no attempt to move that out into a negotiated framework. In these circumstances, of course, the core issue becomes damming, and both China and India are committed dammers. In the main, the dams that are being built are what are called run-of-river dams. That is, that they're being built for hydropower or to try and conserve water and stop unstable runoff from glacial or snow melt. The real controversy will come about the question of diversion dams. When the accusations are made, it's always about who's trying to or intending to divert water from some kind of natural direction of flow. India has about 355 dams planned for the Himalayan regions alone, including the disputed province of Arunachal. India succeeded in getting a grant from the Asian Development Bank to help build dams in Arunachal, and China was absolutely furious about that, and I have a source in the paper indicating China's view of that. China has 750 projects for Tibet alone, many of which are going ahead. The most controversial issue will be damming on the Yarlung Sampo, which forms the Brahmaputra. And if you look at the map, there's something called the Great Bend. The Yarlung is heading straight towards Yunnan province, but then takes a complete 90-degree turn and comes down south throughout Arunachal into India and ultimately into Bangladesh. There are consistent rumours that China will attempt to divert the Yarlung and therefore change the direction of flow of the Brahmaputra. So the lack of trust and transparency between India and China strongly focused on the Himalayan frontier, and India's perception that China is building logistically towards the Tibetan frontier and around the Tibetan frontier into Pakistan and Myanmar, creates a climate in which Indian security and analysts see an opportunity to exploit the issue. So one of the reports that actually is dealing with this question in security terms was produced by IDSA, the Institute of Defense and Strategic Analysis, which is the Indian military's think tank in Delhi. They produced a report just September of this year, and it says, it's important for India to create global awareness about the water resources in Tibet and build regional pressure. Tibet's water is for humanity, not for China alone. Almost 2 billion people in South and Southeast Asia are dependent on the water resources of Tibet. Tibetans need to be also sensitized to the water resources and the ecological damage that China's water division plans can cause. So this is fairly typical statement from India's securocrats. You see the three things it does. It treats Tibet and China as being different places, so they're discussing Tibet and China as if there was an equivalence there. They're talking about building regional pressure, so trying to use this issue to get South Asians to take a particular approach to China's involvement in the region, creating a kind of a threat perception of China, and also, perhaps most sensitive of all, calling upon Tibetans to be sensitized about the impact of China's development plans on the ecology of Tibet. So if you like, trying to leverage the national minority issue against Beijing. That's there because it's a typical statement of how Indian securocrats will try and exploit this issue.
1 minute, Dave.
1 minute, okay. So it doesn't necessarily have to be like the literature which talks about water wars or resource wars generally are not substantiated by proper scientific analysis. So Goffey et al. In 2003 that conflict over transboundary water issues is actually comparatively rare. And even where there's difficult sovereign security issues, it's still been possible to reach transboundary agreements. Nevertheless, they have a set of criteria which runs as follows. High population density, low per capita GDP, overall unfriendly relations, internationalization of minority politics, infrastructure projects, and no water management treaties. That's their checklist for when transboundary water issues get out of control and tend to intensify, and of course, that's a checklist for where China-South Asia hydropolitics is now. So my conclusions, Asian industrialization and urbanization are driving governance agendas within and between societies, and they will increasingly have bridging effects between sovereign security and the security of civil societies, even though many analysts in China, India, and other places haven't got there yet. Sovereigntist instincts and responses to transboundary vulnerability are deeply ingrained in Asian countries, but clearly these responses are inadequate to meet ecological transition in vulnerable common regions like the Trans-Himalayan region. India-China relations are in a bit of a trap at the moment, and they need something to get out of the trap. And there's actually a very positive citation from a Chinese analyst from Yunnan, pointing to the fact that it's possible that convergence on sustainable development objectives will force the Chinese and the Indian governments to get out of the trap that they're in, where sovereigntist politics and concerns about mutual sovereigntist threat take precedence over transboundary vulnerability.